Hi again, it's Tim, your living sky guy from the Paris of the Prairies, beautiful Saskatoon. And I want you to think back, think way back to your very first lesson in astronomy. And if you can't remember what that is, take a listen for a few seconds to my 3-year-old granddaughter Eleanor as she refreshes your memory.
3, 2, 1, blast off! Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, like a diamond in the sky. Twinkle, twinkle, little star, how I wonder what you are.
That's right. Twinkle, Twinkle, Little Star was the very first astronomy lesson that most children in the English-speaking world ever had. For most of us, this 19th century poem by the writer Jane Taylor was our very first exposure to a very simple scientific principle. That principle being, stars twinkle and planets usually don't. But the question is, why? Well, the answer to that question is in the provocatively titled phenomenon known as atmospheric scintillation. And what do we mean by that? Well, atmospheric scintillation, very simply, is the phenomenon where the Earth's atmosphere, which is quite thick, relatively speaking, is constantly in motion, in some cases opposite motion. And when that happens, it creates a refraction of light. It disturbs the light that's coming through that atmosphere. Now, when we look at a star, even the brightest of stars with the most powerful of earthbound telescopes still looks like a pinpoint light source to us. And that pinpoint light source, when it's shining through the atmosphere and the atmospheric scintillation is causing refraction, has a tendency of causing it to blink on and off, or twinkle. Now that twinkling effect becomes much more prevalent the lower to the horizon that the stars are. When you're looking straight up towards the zenith, the stars are much less active than they are when you're looking towards the horizon. Because of course, when we're looking towards the horizon, we're looking through a much thicker layer of that atmosphere, and the scintillation causes more intense breaking of that signal or more intense twinkling. So that explains stars, but why do planets not usually twinkle? Well, the reason that planets don't is they are much closer to us than the stars, even though they're smaller than your average star. But the fact that they're so much closer, they appear to us more as a disk. It's harder to see with the naked eye, but even through a pair of binoculars, you definitely see they're much larger looking than a star. The larger surface area of the planet is less affected by the scintillation. Even though maybe the left-hand side of the star is having its light refracted, the right-hand side of the star is not necessarily. Sometimes you'll see a planet twinkle when it's lower on the horizon and the atmosphere is much more unsteady. But generally speaking, when you're looking up at something bright in the sky, if it's twinkling, it's a star, and if it's not, it's a planet. And all you have to do is take a look outside right now. We've got 4 beautiful bright planets out in our evening sky right now, with Jupiter, Saturn, Mars, and later in the evening, Venus. 4 great examples of very bright planets that definitely aren't doing a whole heck of a lot of twinkling. So sit back, take a look outside in that night sky, watch the beautiful twinkling stars and the glowing planets, and throw yourself back to your childhood when you, like Eleanor, could sing that beautiful, simple song. If you want to continue on this voyage of discovery with me, please click on the subscribe button. And you can also follow my personal exploits on YouTube, Instagram, Twitter, and Facebook. Just search for Living Sky Guy. Clear skies, everyone.